I am Noushin Sprossel. I am the Director of Safety, Health, and Environmental for ship repair here, BAE Systems ship repair business. When I got approached by Michael and team, I was very excited to do this. Teaching and helping others understand why we do things we do has always been a passion of mine. It doesn't matter if it's a kindergartner, Boy Scouts, Cub Scouts, high school level, even in college. So any opportunity I have, I like to share the story of science with you. With that in mind, I'm going to attempt to share my screen with you. And let's see if you can please give me a confirmation if you can see my screen or not. Excellent. All right, so let me move this out of the way. Okay, so I created a few slides. I'll go through them, but before I do, I just wanted to mention that I am not in official on an official BAE system outing here. So just wanted to make sure that I'm not functioning in that capacity, although I might, you might see references to the organization or, name of the business and use of the logos. I just wanted to make sure that that was not, observed as such. So what you're looking at here is one of our what we call a dry dock. This is how we bring ships out of the water when they come to us for repair. So very close probably to what Michelle has shared with us with some of her experiences as far as activities around bodies of water. So you can imagine this water is in the middle, but when the ship goes on it and it comes out of the water, guess what? The ship's on that structure and it's out of the water. So I just wanted to let you look at that picture as an opening, and you might think, what in the world does that have to do with STEM options, or STEM programs? So with that, I've created some slides, and I like the opportunity to just share my story with you a little bit. Different approach than what Michelle has taken, but I find myself in a very rewarding and exciting career. I've been doing this for many years, and my interests still grow. I still don't know what I want to do when I grow up because opportunities are endless. So a little bit of my academic background, I had promised when my parents wanted me to be a medical professional, a doctor. I tried several times with MCAT. I just didn't get selected. So my academic career took a turn. After getting a bachelor's in biology, I was able to go to graduate school. I did apply for NIOSH grant, National Institute of Occupational Safety and Health. And with that, I was able to achieve a dual master's. One was in industrial hygiene, which we'll talk about that a little bit. And the other one was in hazardous material management. So as I went through graduate studies, I was able to continue my career in healthcare. So I did support a few specialists and surgeons at that time. After I graduated, I found myself as a health, safety, and environmental professional in utilities, power generation in South Carolina. My career grew within that organization and environment, and I went to the chemical manufacturing side just to get exposed to more opportunities in identifying what responsible management of chemicals are in a manufacturing world. From there, opportunity came available, so I switched again in the same line of profession into a mining industry in surface mining. So you can imagine how much of the ecosystems they would be impacting. And from there, I landed where I am today with BAE Systems, National Security or defense company. I apologize for that typo there, but. So it's been a long, kind of a turn of events for me, but very much rewarding and very exciting. And just wanted to kind of share a little bit of that with you. I am a certified industrial hygienist, so even within our profession, there is certification and growth opportunities. There are many other certifications on the environmental side and on the safety side. They all do require education and credentials, academic credentials from ABET accredited schools, because many of these areas that I'll be sharing with you, they're highly focused and to be honest with you, would not be possible without you relying on the sciences and math and engineering, as I'm hoping to present to you in the next slide. So a little bit just an overview. This is my health and safety and environmental oversight responsibilities in 3 of our yards. You can see the locations. When you see it from up above, it kind of gives you a little bit of a different perspective. This is Norfolk right here on Elizabeth River. You can see all the number of dry docks and piers that we have with the ships at hand. This one is in Jacksonville, only a couple of miles from the ocean. That's the waterway right here. And of course, in the beautiful San Diego, you can see we also have all the access to the open water and how careful we have to operate as we are right there in the body of the water. So my journey continues. This is a little bit different than your mining facilities, if you will, when you are on dry land trying to dig up, whatever elements or material you're looking for, and certainly different than a manufacturing facility where you're working within the confines of buildings. So just wanted to give that to you as a perspective. Many employees, diverse workforce, many visitors. This is a business where we have to work with, maintaining, repairing, or modernizing, Navy force vessels and or commercial vessels that come to us. So it's a great and tremendous responsibility and pride that comes with that as we operate in these communities. So how does that tie to background in STEM and all the sciences, and what does it mean? How do we take what we learn in school? How have I learned that, and how do I apply it? So safety, health, and environmental compliance is not just something that the companies these days have to do because it's a requirement. I think most of the companies in this day and age want to be a responsible community member, which means they're going to do the right things and above and beyond what regulations at times calls for, which is quite often. So programs that we have to implement safety regulation, safety programs for our employees, our visitors, contractors, health-related programs for the same, especially our employees. And there are environmental regulations and standards. All of those are governed by a certain set of standards. So industrial hygiene, just to give you a perspective, is the study and science of looking at employee exposures to different kind of health stressors. That could be heat-related, chemical-related, could be items such as physical in nature, like heat and cold, radiological, nuclear, biological, all of that, because as a living body, we can get exposed to those things. So the science of industrial hygiene walks us through that. Safety regulations are basically, again, I've tried to simplify these a little bit just for our purposes here, just for discussion. Addresses our exposure to physical hazards at work, such as moving vehicles, control of hazardous energy, rigging material items as such. And of course, environmental protection that we talked about. I think environmental regulations are very much close to also health regulations, but it is a huge responsibility that we have to help the crowds and the manufacturers and all these industries understand. So we are kind of an informal educator on a different scale, and it's a pretty diverse environment. Again, federal, state, local, rules and regulations, and contractual, because in this line of work right now, it is considered a federal a contractor type environment, so we have to abide by those as well. And then we have what we have as a consensus standard. So On the right-hand side, I'll just show you some of those organizations that you might be familiar with. OSHA, Occupational Safety and Health Administration. We have Department of Transportation. Michelle spoke about DOT. There's that one right there for you. They're very much very involved in our world. Anytime you're on public roads, and that's where they get pulled in. NIOSH, we spoke about a lot. NIOSH is one of the CDC companies, Center for Disease Control, and I'm sure you've heard a lot about this one here in the world of COVID as it pertains to protecting against the bioaerosols of the late. NIOSH is the education arm for OSHA, and also within CDC, they do a lot of research when it comes to occupational health. Environmental Protection Agency, National Fire Protection Administration, and also we have ASME, the Association for, this is for the mechanical engineers. These guys or ladies, they do mandate a lot of items on the, for example, ventilation, HVAC, or any kind of structural items that you might be dealing with. And of course, we have the American National Standard Institute, ANSI. They do specify requirements based on science in how strong should a hard hat be, how strong should safety glasses be. NIOSH, for example, tells us which respirators and which respirators actually are protective against what agents or stressors. So just wanted to kind of give you a view, very small aperture into the exciting world of opportunities as STEM proficient professionals, where we can be very gainfully employed for many years to come. So how does it support the SHE process? That's safety, health, and environment. To be honest with you, it's the key that enables us to manage these programs. Without having these sets of skills and knowledge, it just becomes very difficult and very quickly. So that's how you set apart the SHE professionals from, let's say, a frontline employee that might be working in a safety profession or safety profession. So we talked a little bit about industrial hygiene. We have to use the science to identify the hazards, evaluate them, see how much of a hazard it is, and then what are the controls. So as an industrial hygienist, that's what we do. We look at biological, chemical, physical, or any other radiological stressors in the work environment, and we have to know how to calculate those. Calculating concentrations versus, if it's a liquid, if it's a mixture, is it a vapor, is it a dust? All of that comes into play. So you can imagine that you're constantly maneuvering through these pillars back and forth. We look at epidemiological studies to just see what studies have been done before, what is the population impacted, what's the standard deviation, what's our confidence in saying that, okay, I measured XYZ amount, is that good enough, or is that protective or not? So it's a lot of, again, maneuvering back and forth between all these areas, that we get to learn through the STEM programs. Controls are huge. This is where we get to sit and design ventilation. What do I mean by that? Hoods that you see in the lab, or you might have 20 grinding stations throughout a manufacturing floor. So you're going to try to decide how much air you have to pull from each of those locations. How long should the ductwork be? How fast should the fans pull this material in? So all of that relies on your very good, solid knowledge of science to be able to do that. Safety-wise, cannot emphasize that enough. People fall at work, so you got to make sure you have adequate fall protection there. Handrails, guardrails, toe boards, stair height, all of those are designed to a certain specification. So as safety professionals, we have to monitor that. They're grandfather rules. Certain buildings are grandfathered, so you can't just go break them down or do something different. So you need to understand some of those codes that we have to abide by. Cranes, we lift items all the time. How strong of a sling you need? What is the lift angle? Is it appropriate for the kind of lift you're doing? Flammability of compounds that we have to deal with, because that's pretty important. You need to understand the concept of combustion and flammability. How do you what concentrations are the ones that you can tolerate, and what you got to do to control those hazards and mitigate. And we talk a little bit about environmental protection, where we have to know how to calculate flow rates, calculate emission rates. What controls do manufacturing or any business that is adding effluents or emissions to these work environments have to implement? What are the rules around that? And obviously you have to monitor, and there's going to be reporting requirements, because that's what the regulations state, and that's the right thing to do. So key to success, you can see it's kind of embedded in all aspects of what we do on a daily basis. Just wanted to give you a little bit more viewing. I wasn't quite sure to what level of detail we wanted to take this, but as STEM professionals, it just gives you a little bit of idea about the scientific processes that we have to do in the world of industrial hygiene. Identification, if you suspect you have certain chemicals in the workplace, either by looking at the safety data, or if you're manufacturing something, you got to figure out if you have any intermediate products, and you have to rely on your stoichiometry and kind of understand how the molecules behave with each other and what you're trying to drive to. So that's when you have to rely on that data. If you know what you have, they're typically, I just give you some snapshots as examples. You might want to go and evaluate how big of a benzene problem you might have in a work environment. So there is a methodology to be used for you to evaluate that hazard, to see how much concentration of benzene you might have on the manufacturing floor. It tells you what the stressor is, how much air you have to pull, what kind of pump you have to use, what kind of sample media you have to use. And I just put some pictures here to show you what we're talking about here. So you've got pumps that you have to then make sure you calibrate them, material that you have to connect the sampling train. So yes, I've got a pump, but there's a Tygon tubing, then it goes to a sample media, then you hang it up on the people's like shoulder in the breathing zone. You might have seen that, where in manufacturing areas, people are collecting samples. It's really not listening to people talk. It's just looking at actually how to collect enough from their breathing zone area so we can send it for analysis based on what method we were using. Then once you get the results, you can see there are some calculations here, like it shows you the ppms here, it shows you the TLV, the threshold limit value for some kind of a mixture. So you have to calculate the exposure amounts based on those samples and come up with a number. Many chemicals have regulatory limits that basically states below that limit there is no indication or studies that have shown that there is adverse impact. Now, unfortunately, some of the regulatory atmosphere, such as in OSHA regulations, those permissible exposure limits are very old. So we rely on other organizations that have updated data in what values to use for that. So you know how to measure, you go do measure properly with the right equipment. Then you calculate it, then you're going to look at, okay, how am I going to eliminate that hazard? So engineering controls, that's where you actually eliminate the hazard out of the way. Obviously, substitution is the best thing. If you can't substitute products, you have to probably look at major engineering controls. So that's when we sit down and design ductwork, fans, hoods. This is, again, just a very brief example for you guys to get an idea about this. And once you do that, it might not still be enough, because you might still have exposure out there in the field. So you have to then rely on personal protective equipment. But which one you pick is important. Cartridges mean different things, especially if you're dealing with some kind of respiratory stressor, based on let's say if it's an organic item versus particulate, there's a science behind that. But then you can't just expect people to wear these kind of respirators that are tight fitting. It makes a seal on your face. You have to do a fit testing to make sure it's adequately protective of what's out in the outside environment. So when the air passes through those filters and through those filters only, then it's safe for the employee to be in that atmosphere. But you still need to know what is the protection factor for this kind of respirator versus what firefighters wear, like an SCBA, the self-contained breathing apparatus. And once you do those measurements, you put them in a respirator, but you still got to sample on and off to manage that. So your sampling activities never stop. So you do continuous maintenance. But as you can see, we got to be cognizant of what we are sampling. You need to know the anatomy and physiology of a human body, know what the toxicology of the chemicals is that you're dealing with, rely on the chemistry and know how it interacts with the human body in terms of the target organs, do the math on appropriate calculations, look at your statistical data, look at epidemiological data that you might have, look at the physics, because this is, you're looking at all these ventilation calculations. And last but not least, on top of the STEM activities, we always got to be aware that we're dealing with human beings. So your employee relations, how you communicate this, how you educate your employees so they know that you're not reading their kind of, brain waves when you are doing the fit test here at this in picture. It's amazing what you find yourself trying to explain to your workforce, but it's exciting. I hope I'm painting an exciting picture for you in all the levels of STEM that is involved in the world of industrial hygiene. Moving on a little bit to safety, trying to look at the time and be sensitive to that. Lots of mathematical calculations, lots of looking at physics concepts, and of course the chemistry when it comes to flammability and combustion materials as well. I gave you some pictures here. For example, being able to calculate force, fall protection, where can people tie off to, right? What force should that anchorage point maintain or offer for somebody to be able to tie off to, so if they fall, that vertical force will not cause a failure of the anchorage point and cause a fall or hitting the ground. Cranes and lifting, there's a science around signage, how they move the crane around, but more important than that, before they can even lift it, how do you calculate the load? Has that load reached a certain capacity of the equipment? What are your programs in managing that? At what point do you draw the line as a threshold? Electrical energy, the high voltage energy, that's pretty important program, especially in utilities companies. There are gurus at working with that, but at manufacturing or even in our homes, there's a lot that goes behind that. You got arc flash, you got to understand the resistance, you got to understand the conductivity. So there's a lot of physics that goes behind that as well. So we need to be very much aware of that. And I do believe the last area I just wanted to spend a few minutes on, again, echoing on what Michelle had shared with us, environmental protection. You have Clean Air Act that protects against many of the emissions that come from industrial activity and vehicles and other things we do. It does impact our air. So a lot of industry is regulated. Believe it or not, just as a few examples, even in a shipyard, you might think, well, what does shipyard have? They don't have a smokestack. True, but we have emergency diesel generators. We have all kinds of other things we have to work with within the confines of the environment. Water. Water is a very valuable resource for us, and you saw where we sit. We are familiar with the Elizabeth River project. We do have some projects actually that we support on our sites as well, but any water that we use and also any water that we treat and return back to the environment, we have to manage that. there might be dredging involved, there might be all kinds of things involved, but the entire science behind that is at play also. We have to take samples, we have to look at the effluents, make sure what concentrations are the chemicals that we have identified or are identified on the permits need to be levels, what levels they need to adhere to, be, for us to be able to discharge back to the body of the water. Hazardous waste regulations are very strict. You can't just throw anything away just because we assume it is, okay. We have to index the waste. We have to analyze it. We have to determine, yes, this is just office trash, we're good to throw that away. Or if we have a can of some sort of ethyl, methyl, yuck, we're going to have to analyze it, make sure, okay, where does it go? Do we just put it in this container versus here, and where does it end up? Because the hazardous waste regulations, you might hear about this, cradle to grave. It's the responsibility of the manufacturers or the people that generate that waste under that EPA ID number to be responsible community members and make sure they do the right things with it. Then you have reporting of chemicals, any chemical we use, if they are on a particular list that EPA has available, we have to report how much we have used of them. Some thresholds are as low as about 10 pounds. So you can imagine when you're looking at a multi-acre facility, what rigorous methodology has to be in place to calculate, even based on a percentage of that particular chemical weight-wise that you have used and released to the environment by the virtue of having used it. So lots of activities. Again, it brings calculations, statistics, modeling, because you have to kind of be able to guess how much a process might emit into air or in a body of water that you have to treat before you release it. So many opportunities in this front as well. So what lies ahead from a STEM perspective for me as a true STEM professional, that I have to use it is applied. It's not just in theory. We have to make sense of what we learned so we can apply it to our environment. It is there to help us identify and assess the hazards, no doubt. It is important to be a STEM professional so we can eliminate those hazards using those skills and knowledge. We have to use it to implement effective controls. Absolutely is imperative. It also promotes responsible communities. You might hear of sustainability. That's a buzzword. That's what it is. You rely on the science. Okay, how can I recycle something as opposed to creating more waste? So you look at your chemical composition potentially, just as an example, can I substitute that product with something else that gives me the same kind of reaction, but it's not hazardous to the community, to the environment, to the people at work? Although you have control means, but you always want to be a more sustainable company. And for me, I hear a lot of argument about artificial intelligence movement. A lot of people think, oh my goodness, it's going to take the job of the people away. I don't believe it. You still need the proficient professionals that know the science so they can interpret that data, make sure that it's looking at the right things. So it's a very exciting future, actually, when you pair up the STEM programs with the artificial intelligence, and that is a very exciting world for us. So I do believe this is my last slide, if I'm not mistaken. This is my contact information. I'm going to open the floor to some discussions, and again, Mike is also with us here from our HR team, and I'm certain he can help us with resources and questions that you might have. So Kim, I'm going to turn it over to you for any questions.
Yeah, we do have some questions. The first question we have is, could you explain the difference between OSHA and NOISH? I don't know how to say it.
NIOSH. Okay.
NIOSH, yeah.
So NIOSH is the National Institute of Occupational Safety and Health. So they do a lot of research, they collect data. They're a tremendous resource. We refer to them as the education arm for OSHA. Not 100% true, but what they do a lot of education and research camps. So based on what they do in different arenas, it could be fall protection, it could be some kind of a toxic chemical, or what they do, they actually do studies, they do measurements, then they do the epidemiological statistical analysis. And based on that aspect, the information is made available to the industry. Now, I can tell you that NIOSH is a very important player for respiratory protection. Again, I'm not referring to just these masks that we wear these days for COVID, where actually they define what a respirator is. They actually have to have a certification, not just for the type it is, but also the cartridges that go for what chemicals. So that's what they do. Now, OSHA is actually the regulating agency. So there are some states that have state OSHA, which means that not only they have to meet the federal OSHA requirements, they can be more strict, okay? So OSHA will enforce compliance for your employer. If you're like in a state program, they enforce compliance for industry. They have different branches of course, it's a very vertical type organization. You have maritime for ships. You could have, then you also have another agency under Department of Labor for mining. So they regulate and they enforce. Hope
Awesome.
that answered you.
No, thank you so much. I was you mentioned both, and I was like, okay, I'm hearing occupational like safety and health, but I'm not actually. I actually just occurred to me, don't know the difference between the two.
They are. There's a lot out there. You have local jurisdictions that apply, especially in California, as far as environmental requirements. So yeah, it's very multifaceted. It's absolutely fascinating. You have to kind of have a pretty good understanding of what regulations and standards apply to what you do. So.
And I guess speaking of all of the things that you just spoke about, I mean, I guess I'm assuming that you don't do all of this. So I guess who do you work with? Who's doing some of these things that you've referenced?
Yeah, so I don't do all of this by myself. I can't possibly. I do what I do because I have a great team. We have a large population of, I call safety, health, and environmental professionals at each location. We have safety professionals, we have health professionals, we have clinics at all the sites. So everything is pretty well defined, and at each level, they have to have the right set of skills. And training is ongoing. You constantly have to keep up with training. We are also, part of associations. There's several that help with resources. I mentioned that I was a certified industrial hygienist. That's through American Board of Industrial Hygiene. That accreditation is actually recognized globally. We do have other agencies that do offer certification, local agencies, other associations, for example, Virginia Ship Repair Association right here in Norfolk. And it's a very nice association for the ship repair industries in our area. BAE is not the only one. So we do meet on routine basis, and we do offer educational opportunities for our employees. So there's many courses that we send our technicians to help us run these programs.
Awesome, thank you. And we have a question here, and I guess this is something that, I mean, I've certainly heard this too, is, like, do you guys do underwater welding at your facilities? Because I know, like, just in terms of, I guess, dangerous jobs and safety stuff.
Right. I could tell you this. We do have specialists that do that job. It is a niche. It's something that you don't want to just have your welder that welds above the water to go underwater and do. So it's very likely that we have professionals hired in as a contract basis to do that kind of work. Yes. Yes, and it's you know, I mean, as you can imagine, I didn't speak at all to the security. That's another layer of regulations that goes on top of this. But yeah, so a lot of consideration, but that is certainly a unique and exciting opportunity to go under the weld at the same time.
I have a friend who's really good at welding, and I've been trying to convince him. And he's like also really likes diving, and he's just like, yeah, but I don't like welding that much. And I'm like, I'm just saying you can make like a lot of money. And he's like, yeah, but I just hate welding. And again, speaking of all of the things that are happening, I guess what parts, I mean, because you mentioned doing biology for, an undergrad, I guess, how does that inform and help you with all of the things that you need to look at and try to figure out and calculate? Right.
So anatomy and biology, right? I mean, I've always been passionate about it. I was, very good at biochemistry. I wasn't very liked from that perspective because you can ruin people's curves. So I've been guilty of that before, but it always made sense for me. And then when I did not get to medical school, I always look at those situations as an opportunity. I believe that if as any professional or any individual, if you have given it all and some things don't happen, I would not look at that as a negative. I think we need to look at those opportunities truly as an opportunity that they are. When that did not happen for me, I was pretty good at biochemistry. I heard about the industrial hygiene program. I loved it because I had to use the knowledge of how Krebs cycle worked, how mitochondria worked, how the muscles work, what does the lung do, what does the kidney and liver do? Because anything that you inhale, your body has to process it and get rid of if it can. So it's either involving your kidney, liver, your skin, your lungs. So that's how the two got connected. As I studied more about it, I also, during my graduate studies, found out how close it was related to the environmental regulations and the hazardous materials. So it was a natural choice for me to get the dual master's at that time, because I think it's connected. As professionals, everything, if we keep that in mind, the science will guide us through what we have to do and make the right decision. We got to adhere to scientific approach on everything we do.
Oh, thank you. Actually, I really enjoyed that answer.
Okay, good. Well, glad you liked it. And I really mean it. I really go by that. I'm a true believer.
No, but I mean, so to be fair, I have a biochemistry degree. I have never used it. Turns out I hate lab work. And I thought the only other thing you could do was become a doctor. And I didn't want to do that either. So then I ended up in education. But I will say, certainly that having a biochemistry degree helps me all the time with putting together reports, figuring out, my latest passion project is figuring out how to better communicate to educators and everyone, like what are these post-secondary pathways and education opportunities? Because sometimes it seems really confusing, but I actually don't think it's that hard. I mean, it is a little hard, but it's not as hard as I think we make it. All right.
Thank you so much.